Hello guys, this short video is just going to kind of go over your observing mechanisms assignment, just so there's no confusion. So on Google Classroom for today's work at home, you need to open up observing mechanisms. I'm just going to go to robotics, bell 3, bell 4, you guys are the exact same stuff, observing mechanisms. It says use the mechanisms gear ratio intro slideshow to help you complete the mechanism notes Google Doc. So you're going to be using this yellow slideshow here to help fill out this one. You're only doing problems 1 through 7. Okay. Let's go ahead and look and see what we got. So let's go to the slideshow first. This slideshow, you can probably look at it and figure things out, but if you were in the classroom today, I'd be talking about it and really giving you a lot more information than just what you see on here. So a mechanism is just a part of a machine. Think of gears as a good example of a mechanism. Pulley system is a mechanism. Lots of different types. We're going to be learning 12 main types that are used in engineering. Okay, what are they used for? Change the direction, changing the type of movement, and changing the speed. Also changing the torque, which in class we often just call force. Okay. Let's get into gears first. Okay, when gears are together and turning another adjacent gear, we call that being meshed. And for gears to work properly, they have to be meshed. The teeth have to line up. Okay? Gears always turn in the opposite direction of the input gear. Okay? Another term we use is flow of power. The flow of power is reversible only if you can rotate the last gear in the chain or the output gear and get the original first gear to turn. So, if I turn this gear here, this is my input because I'm giving it input, I'm turning it, and it makes this one here on the end turn. Okay, the flow of power is reversible if I can turn this one with my hand and get this one at the beginning to turn. Some systems are not reversible. It won't work that way. Gears, meshed gears, are an example of flow of power being reversible. Okay, mechanisms change movement. We got different types of movement here. This kind of movement here is going around in a circle, round and round, and the way I remember that, round means rotary, or to turn. Reciprocating is going back and forth. Okay, and then there's rotary, circular, reciprocating back and forth. And then linear is going in just one direction. So it's like reciprocating, except reciprocating back and forth. Linear is just, see, this is the input, which is the round gear, and it's making this rack gear go in one direction, linear. All right, gear ratios. This is where things get into more mathematics. Okay, gear ratios always compare the output gear, which is the one on the end. Think of it this way. This is my input. If I'm turning this with my hand with a crank handle or something, this is the input. So this big one is going to be the output. It's actually going to go this way. Okay. When you write a gear ratio down, you always count the teeth on the input gear. You count the teeth on the output gear. Here we got 80 on this one and 20 on this one. But you always write this ratio as output over input, which you probably have heard from mathematics class, slope and things like that. So I'm going to write the 80 first. That's the output gear, which is this one. And 20 is my input gear. And then we reduce it. So I can divide both and get 4 to 1. So the gear ratio here is 4 to 1. I'm not going to talk through all this. You can look at it, but you can see this looks a lot like the mathematics you've probably done. Output over input. So for example, here we have a 12 tooth and a 36 tooth. The 36 tooth is our output gear, so it goes on top, okay? And then the input gear is 12, it goes on the bottom, and we divide both and we get 3 over 1, or 3. So gear ratio is 3. This is just a slide that shows you all the different types of gear ratios that we use in this class. These are all the different gear sizes that we use. Okay, this here talks a little bit more about gear ratios. It's basically what I showed you earlier. Just know the input is not always on the left. I know we've been doing that. If I was to turn this one with my hand, it is now the input, and this one would be output. So you always got to know how those go. Now, I want to give you some tips to help you remember a few things here. Okay, so let's look at these here. If the output gear is larger, that's this one, than the input gear, then the speed will decrease. So imagine if I'm turning this little gear, this is my input, and the output is a larger gear, it's going to be a slower rotation. I'll have to turn this one really fast, and this one here still won't be as fast, it will be slower. It's because it's got a larger circumference, takes longer to get around. You will see that like on bicycles. You will, if you switch gears, you might be having to turn this one really, really fast, and this one will be going slower. So that would be like if you want to go uphill or something. And this one here, if the output gear is smaller, which it is, okay, that's going to be built for speed. You're going to get greater speed because you don't have to turn gear A very fast, and yet gear B will go very fast. So speed will decrease. Now this is an inverse relationship. So if speed decreases in this first example, then that means power is greater, more torque. And on this one, since the speed increased, our power is going to go down. So if you wanted to go really fast on a flat surface on your bicycle, you'd want to do this one here. But you would not want that to go uphill because you have very little power, and you'd have to switch gears because you would have a very hard time making it up the hill with this gear ratio. So if you ride a bicycle, you probably know what I'm talking about. Now, here's an easy way to remember it. If you put a line on top of your gears, you can see that the line is going up because this gear is bigger. This is a great way of remembering speed and power. So if I'm going uphill, I'm obviously going to go slower. Speed decreases. So I use this as a reminder. Put a little arrow in there. If it's an uphill, your speed will decrease because it's harder to go uphill. And then on this one here, going downhill is really fast. Very easy to go fast. And so if you ever have a downward arrow from a large gear to a small gear, okay, you're going to have increased speed. So that's one way to kind of visualize it and see it. All right, I'm not going to go through the entire slideshow because this video will go on forever, but I do want to move on to a section that you're might be a little confused on. So all this stuff here you're going to complete because you watched this video or you looked at my slideshow. This part here, you need to label your input and output gears. To do that, okay, you just click on it. Actually, I have to take it back. You have to double click. It opens up the drawing. And then you're able to click and drag these arrows. So you could say, hey, this one's the input, this one's the output, vice versa. So you're labeling them by moving the arrows where they go. Okay. Need to show that because a lot of kids got confused. They didn't know how to move these. You have to double click to open up the drawing and then do that. These here, just go ahead and answer on the blanks. Okay, and this stuff here you're going to be doing the next day. So you don't do this today, but I'll just show you since we're on the video now. This is for your next at-home learning day. This one here, same thing. You got to double click it right? Double clicking will open the drawing. And then what I want you to do is label the input and output. So you're just going to drag these words over this part of the device that is either an input or an output. Okay. Trust me, it'll work. I'm not going to move them around because it'll mess up the master drawing. But you drag these onto what those would be. All right. Hope this video helped. Good luck, and I'll see you next time.